Hi, everyone. Please get ready for our next tutorial by Dion McMurtrie about mastering FHIR terminology. So, Dion, are you ready?
Ready to go.
Please. So, the floor is yours.
Okay, great. Thanks very much. Okay, really this presentation or this tutorial, we do a lot of presentations that just talk generally about the introduction to FHIR Terminology Services, and I thought it might be interesting to delve into some of the deeper techier bits. So hopefully everyone's here for that, and talk about some of the deeper features. So I guess I'll start with the obligatory side of who I am. So I'm Dion McMurtrie. I'm a team lead in the Australian eHealth Research Centre, which is part of CSIRO. So CSIRO, for those who don't know, is Australia's national science agency. So it's a reasonably big organisation responsible for radio telescopes and Antarctic research vessels, and we invented Wi-Fi, so you're welcome. So there's lots and lots of stuff. So we're the digital health part of that, and probably, at least here, probably most famous for OntoServer is one of the things we do. So for this presentation, I really just sort of cherry picked a few things. Hopefully I haven't been too ambitious with the amount that I can fit into this time of things to talk about. And there's many more things I could have talked about. I ended up picking these. So CodeSystem Supplements, go through what they are, what they're for, and how you use them. Implicit value sets, and trying to get people to be aware of what they are and how you can use them, and particularly SNOMED CT ECL, and there's a bit of a surprise in there. Transitive closure table, I know I've been asked many times about what this is, and I referenced this in the presentation or tutorial yesterday, and only had a very quick example, so this gives a little bit more detail of what that is and how you might use it. And then composing concept maps, and we'll get into some detail of when and how you might want to do that and how that works. So there is a little bit of assumed knowledge that I have of this, that if you went to the presentation yesterday, you'd probably have enough to get this, but I'm sort of assuming you've got the basics of the FHIR Terminology Services, at least the three main resources, how they relate to each other, and the basic operations for those, and a bit of an understanding of code systems and how they have properties and hierarchy and that kind of thing. Just before we get started as well, all the resources and requests that I demonstrate in this presentation are all up in a Postman collection that you can go and play with and run all of these and tweak them to match other examples that you want to try out. So that's all good to go. And that Postman collection runs against OntoServer, which is just our public sandbox OntoServer instance that you can go and play with and that kind of thing. So that's just what that is. Right, so code systems, and code system supplements. So there's heaps and heaps of code systems now available that are maintained by other people, which is awesome, because if you've ever maintained code systems, it's really great when other people do it and you don't have to do it yourself. There's heaps of them in the HL7 code systems, which you're probably all quite aware of. There's big, large published ones like Loink and SNOMED CT and RxNorm and UCOM and all those ones. And then there's a bunch of other sort of local and regional code systems that get published by a variety of different people. But there's always that problem of what if you need to, customize that code system in some way, change what a display term is for a code, or be able to translate that code system into another language, or maybe multiple languages, or add properties to the code system. So you can ask the maintainer to try and do that, but if it is a generally useful thing, that might actually be a really good thing that you should do. But you don't necessarily control if and when that would happen, and really whether that's in scope for them or not. So this is where code system supplements come in. So a code system supplement can be used to extend a code system with properties and with designations. So any properties, but also designations in terms of adding different synonyms, but also complete language translations if you wish. But they don't allow adding new code. So this isn't a way to to go and change the code system and add a bunch of other things into it. It's a way of kind of attaching things to the existing codes that are in a code system. And obviously you end up using it in the context of a value set, so it'll affect the expansion results, and you can do things like changing what the display is to maybe to another language or a different preferred term, or you can add in other available properties. And I've got some examples of how to do that. Just a slight segue before we go on to that, and Graham was talking about this earlier, and I think Lloyd's talking about it now, or just finished talking about how internationalization and translation works in FHIR. So, of course, there's another DevDays presentation. In fact, we've got the speaker here that talked about the multilingual support. In terms of this presentation, I mean, there's a page that talks about many aspects of that. Really, it's this page, this languages page, but effectively for the requester, it's really just HTTP. So there's request headers, your accept language header to say, what do I want the response to be? And then the response header of content language to say, this is what this response actually is. There is also a display language parameter, and then all sorts of variations of the resources base language and the request headers and display language, but we'll gloss over that for a minute because that'll take ages to talk about. But if anyone's interested, we can talk about that after. So here's an example of adding a translation to a code system. So we've got you can see at the top here, this code system is describing itself as a multilingual administrative gender code system resource. But you can see at the bottom, and hopefully you can see it at the bottom, its content type is supplement, and it's specifying what it supplements, and it's supplementing the administrative gender code system. And I don't know if she's here, but this is actually stolen from a friend, Ruth Lindstrom, who's possibly somewhere around here. And this is just one of the concepts from further down in the code system. And you can see here that, as an example, it's adding onto the code this Portuguese display term. And you can see that there's others in there for Spanish and Estonian as well. So it's actually adding 3 different languages onto this. So in order to use this, and this is in an R4 context, we need to be able to tell a value set that it should use this supplement when it's calculating the expansion to return back to a request. So that's what this extension at the top is doing. It's saying when you process operations for this particular value set, this is the supplement that you should engage to do that. And then at the bottom here, this example value set is just everything in administrative gender, which really isn't very much because there's only 4 codes or something in it anyway. But obviously it can just be an ordinary value set with all sorts of inclusion rules or whatever else you might need. In R5, there is another parameter that isn't in R4, which is this use supplement parameter. And that can be passed into the expand operation, and it's basically the same as the extension that's up there. But obviously, you don't have to provide that in the definition of the value set. You can do that when you call the operation. So using the translation supplement. So this is just making a simple get call to expand that value set, and it's passing in the accept language header to say that we want an Estonian result. And this is the response. So you can see down here that it's actually returned in the parameters that it's used both of these code systems. So it's used the base code system, but it's also used this multilingual administrative gender supplement. So it's letting you know what it's done, how it's got this result. And then you can see here the particular display terms are now Estonian, and I won't embarrass myself by trying to pronounce those. So I only speak one language and I don't even do that very well. So I'm sure Ruth can tell you how that works later. So adding properties, that's the other sort of example that you might want to do with CodeSystem Supplements. So once again, here's a supplement. It's specifying once again that it's a supplement. It's supplementing LOINC 2.74 in this case. It's also specifying the details of a property that it's going to add to the code system. And then this is a fairly dinky example in that it's got one concept in it, so it's only annotating one concept. I guess that's probably worth understanding that we don't have to do all of the concepts in the code system, just the ones that we want to add these properties or display terms or whatever to. And in this case, it's adding this preferred unit to this line code. And this is an example of the actual value set itself. So once again, we've got the same extension saying when you expand this value set, use this supplement. And the definition is, once again, nice and simple, just everything in LOINC, but it could be some subset of a LOINC. So here's another request, hopefully using a parameter that people are familiar with as well. So when you do a value set expansion, you can say previously couldn't, so you just have to do an expansion, you'd get a list of concepts. And if you wanted to know some property of those codes for some use case that you had, then you have to go and look those up or do something else. Now you can say to the expand operation, look, I want you to return the codes that match this expansion, and I also want you to include this particular property from those codes, or more than one property, or all of the properties if you want. And so we're saying that preferred unit property that we added before, we're saying we want that added to the expansion result. And that's what's happened. So this was an expansion with a filter. So the first concept to match the filter is the one at the top there. It's not actually the one that we annotated with anything or added the property to. The second one here has got this extension, and this extension is showing the property that's been added into the code system that we had in our supplement before. So to talk about real life examples of this, we've actually been involved with a few different projects that have used supplements for different purposes, but probably a relevant one, particularly because we're in the Netherlands, is LabCodeSet, which is published by Nictus. And it is a bit more complicated than this because it has other pieces as well, but it adds a status property, a material property, it adds some UCOM units, and it also adds translations, Dutch translations. So there's a sort of real example of why you might want to do this kind of thing. We do see this a bit with pathology as well, having these lists of codes that we're going to say, oh, this is the response codes that we're going to all agree that we're going to use, but we also want to say, actually, we want to make sure that when we use this code, we respond in this unit, or this is the preferred unit. So these kind of additional properties, and we've seen that a bit in a few different countries. So in terms of implications for validation, so you can see here that a value set can say, in the context of that value set, the display for a particular concept should be this text, not whatever the ordinary display term is for that that code in that code system. So that's a mechanism that exists, but really for those implementation guides or resources to validate correctly, that display out of that value set really should match one of the designations from the code system or from the supplement. So we're not actually saying that you can just come and add whatever random text you want. It's got to be somehow referenced back to the code system or the supplement. Okay, so that's sort of supplements. If we move on to the idea of querying, and this will kind of lead into implicit value sets. So if I want to query a code system, and let's say SNOMED, I want to know all the things that are both edemas of the trunk and disorder of lung. So I just want an ad hoc query to say that that's what I want to know. So the old way, first I'd have to make a value set. I post that value set to the server. So this is a kind of a minimal looking value set on the right-hand side, which is just saying all descendants of this code and all descendants of that code. So to be a member, the code must be descendant of both of those things. And then after that, I need to expand that value set. So I can do a GET request, and I can get an expansion of all the things that are in this case, you're getting pulmonary edemas. But if now I change my mind and I say, oh, actually, I really kind of want to know what the lung disorders are that aren't edemas, how do I do that? Well, I update the value set, I put it back into the server again, and now it's got a different definition, and then I expand it again, all of which is obviously a bit cumbersome and tedious, and certainly not conducive to sort of quickly ad hoc querying and changing So there's kind of an alternative with the existing ValueSet expand operation. So you can actually, rather than putting explicitly the ValueSet into the server, posting it into the server and updating it, you can just post the ValueSet in the body to an expand request. And what the server will do is use that definition of that ValueSet from the body, calculate the response and return it to you, and then drop the ValueSet on the floor because it doesn't need it anymore. So that's a way of doing it. It's still a bit tedious because it's quite a lot of stuff to put in there. And it's a post request, so it's not going to cache very well in web caches like a GET request would. So implicit value sets. Implicit value sets are awesome for this kind of use case where you're making queries that are ad hoc, or they're changing and you want to tweak them, or you're wanting sort of dynamic functionality, which we'll get onto an example of in a moment. So implicit value sets exist for a bunch of different code systems: SNOMED CT, LOINC, FHIR, and they're defined in the FHIR specification. This is an example for SNOMED CT, and this is the page, or the reference on the page that defines these. So SNOMED's got a few different types here. So the first one is just all of the codes in SNOMED exists as an implicit value set. So you don't have to create these value sets as value sets on the server. The server, once it's got SNOMED loaded, just knows that when it sees this URI pattern, it knows that that means this particular set, and it will return it. The second one is effectively all subtypes of a particular concept. So descendants. The next one, I'll go to the one after that. The SNOMED has a similar concept to value sets in a way, in that there's reference sets. So reference sets are collections of SNOMED CT concepts that have a particular purpose, and they're distributed within the SNOMED distribution. So you can access those all immediately as implicit value sets without having to redefine a value set explicitly for each one of those reference sets. So you use the pattern that's down here. The one above that actually is a value set, implicit value set, that you can use to say, what are all of the reference set concepts? What are all the IDs that are reference sets in this edition of SNOMED? And it will return what all of those reference sets are that you could then use in the request below. So this example down here is that ISA example, so all descendants of this concept. But this one down here is kind of an interesting one, which is ECL. So SNOMED CT has an expression constraint language, which is kind of like a query language that you can use to describe a set of concepts within SNOMED CT. And there's support in FHIR for that. So you can put a piece of ECL directly on the end of this URL, or this URL that you can send in as an implicit value set to expand, and the server will just expand it like it existed. And so there's almost kind of like an infinite number of implicit value sets because of that. So a really, really brief overview of ECL, because it's a pretty big topic in and of itself. So essentially, it just is a way of describing a set of conditions for matching concepts against that then get included in a set. So there's examples here of like descendant. So you can, on the right-hand side is examples of these. So all descendants of clinical finding, you can say descendants and self. So that would be all descendants of diabetes mellitus, including diabetes mellitus, the concept itself. You can have just direct children and not the rest of the descendants. You can have just direct parents and not the ancestors. You can have all of the ancestors, members of reference sets. There's quite a lot of syntax invented for that. It gets even more complicated, as you can see. So you can say, I want to know about things that are a disorder of lung that have an associated morphology of edema. And you can also start to associate it, if you look down at this attribute groups one, that this is looking for a clinical finding that has stenosis in the pulmonary valve structure and hypertrophy in the right ventricular structure. So you can kind of group those different morphologies with the different sites and so on and so forth. And there's a lot more syntax than this. Here's a couple of other kind of interesting examples. So the first one there, using concrete domains to say, I'm interested in oral dose amoxicillin products that have between 250 and 800 milligrams of amoxicillin in them. So you can say all of these kind of relatively intricate things. I think probably the other one that's really interesting to point out is the next one down, which is talking about the fracture of bone. So this particular request actually returns all of the concepts that are targets of a finding site relationship from any of the fracture of bone concepts. So effectively, it's going to return you anatomy concepts that are places where fractures of bone can happen. So yeah, quite a powerful language, heaps more. Couldn't even go close to explaining it all. But if we have a look at the WIMs that I had before as implicit value sets, this is what we end up with. So you can just fire these GET requests directly at the server with no warning to the server, and it will come back and it can evaluate these quite quickly. So the first one is the first example I had. So everything that's well, I think it was a lung disorder and an edema of trunk. And then the next one after that is everything that's a lung disorder minus all of the things that are edema of trunk. So and you can just fire those and they'll get cached. And so they're a lot more agile, easy to use, cacheable. There's an ECL builder built into Shrimp, which is kind of our browser, FHIR Terminology browser. But there's others as well. SNOMED International has one. There's heaps floating around. So they're really, really great for ad hoc queries. Another really quick example is this one from the SNOMED UI, which is kind of, it's a cool example because it's trying to show like a mock UI for an EMR, but it's showing how the individual fields and the user experience can actually be for a clinician rather than the poorer kind of experiences they might have. But one of the features that it has, and there's lots more going on here that you can go and have a look at. If you see down here, it's chosen a lung excision procedure here, and then you can see on the right-hand side, we've got the option to choose whether it's left, right, or left and right. I guess if you're having a left and right lung excision, you've probably got a serious problem. But but anyway, the idea is that you can change, you can define the behavior of another field by the value present in one of the other fields on the screen, and they can build through that. So this is using ECL. So these are the other examples of selecting other things that actually aren't lateralizable. So therefore, you don't get an option to choose what the laterality is because the UI already knows that that's not possible. And this is just using ECL-based queries to do this. So picking it apart, and it's a bit more complicated than this, and you're welcome to go and have a look at the way that code works. It's open source and you can see how it all happens. But effectively, the first bit is about finding the procedure. So this is just all of the procedure descendants, and then there's a filter of what someone's typed in, so lung EX, and that will return lung excision, or return those three are the top three results. And so if we've picked lung excision, you can see this next example down here is saying, for lung excision, the thing that we've picked, the procedure side of that lung excision and all things that are lateralizable. So I'm going to either get 0 results from that because I'm going to find out that the procedure site for the lung excision is not lateralizable, or I'm going to get back the procedure site because it is lateralizable. And that's what that expand request can do. So that's a kind of a simple way of finding out where the laterality is there. And there's lots of other examples you could do with this sort of thing. So that's really awesome that SNOMED has that feature, and it's really handy and we use it quite a bit. But wouldn't it be great if all code systems had a language like that, so that you could fire these kinds of requests based on their properties at the server and be able to do basically exactly the same thing as you can for SNOMED, but for other code systems? Well, it may not be just a dream, and this is kind of a plug for Michael's talk. So if you see Michael around, you can ask him about it, but he's going to be talking about a prototype that he's built up of kind of ECL for all FHIR code systems. So you can do exactly the same kind of thing, but for any FHIR code system, which is quite good. So quickly moving on to hierarchical queries. So again, this is try to explain what closure is about and why you might want it. So we can ask questions of the server like this to say, these two codes that we have here, how are they related to each other hierarchically? And that's what the subsumes operation does. So we pass in code A and code B, and it will come back and tell us the outcome down there is subsumes. So that's telling us that the excision of liver subsumes the total left lobectomy. But of course, that's kind of one code at a time, so that doesn't necessarily scale that well. I mean, obviously you can fire batches at the server, but it's also just one code at a time. So this is what transitive closure tables are all about, and I've been asked this a few times about what are they really for, and the yellow brick code talk goes into this a little bit, but this goes into a bit more detail. So effectively a transitive closure. So if you look at a hierarchy here, and that table on the side there, that's showing what each one of those edges are in the blue lines between the boxes of that hierarchy. So there's a relationship from B to A, from E to A, from C to B, D to B, F to E. So if I calculate the transitive closure, I'm just adding in those transitive edges, the orange edges. So I didn't realize how appropriate the orange was in being in the Netherlands, but there you go. So we've added in C to A, D to A, and F to A, which are the transitive links. And then you can do things like this. This is what most people are doing this for, so that I can join this from my record table to the transitive closure, where I'm joining the condition code in the record, the fictitious record table that I've got, to the source code in the transitive closure table, and I'm joining to where the target on the transitive closure table is A. And so that's really going to tell me, it's going to return me all of the records which have a condition code that is some type of A, one of the descendants of A, because there's all these links that have been calculated out here in this table. So that's really what those transitive closure tables are used for. So in terms of FHIR, where do they come from? How do you use them? In the implementation guide for SNOMED CT, there's an algorithm there for calculating the transitive closure for SNOMED CT. It's no great surprise that it's pretty big, and it becomes pretty unwieldy. So the closure operation in FHIR is a little bit different in that it creates a transitive closure just for the codes. You can do just the codes in your data. So you might have a diagnosis field. It's bound to a value set that is, 100,000 concepts, but in your actual data, you might only have 5,000 things in your actual instance data. So you can find out what are the relationships between those 5,000 and not the 100,000 things. So it's a stateful sort of operation that you're kind of communicating with. So the first thing you're doing is initializing it and saying that I'm going to be talking about this closure table that I've given the name DevDays 23 DMC. The next step is that you're going to then make a query to it and give it some codes to say, I want to know about the relationship between these things. So these two codes that we had before from the subsumes request, and it's giving us back basically the same answer. It's saying that one subsumes the other code. And then after that, I can add these additional two codes that I've got down the bottom here. So the request isn't actually including the top two codes. We've already done that, and the server already remembers those for the table named DevDays 23 DMC. And it adds in these two other codes, and it responds back to us with just the new relationships that exist between the two codes that we added and the existing codes that it already knew about. So it's a kind of a compact response. But of course, we can, if we want, we can go back to the server and say, hey, look, I've completely forgotten about all of the codes that I've sent you, and I just want you to send me all of the relationships and things that you calculated based on all of the stuff I've told you about in the past. And it'll come back and tell you what all of those are. So there's all of the various responses. So what it's sending you back when you ask for a closure is a concept map. So it's a sort of common format. So speaking of concept maps, so talking about concept map composition. So I talked about this the other day. These are the main resources. Really, this is just to say that with concept maps, context is absolutely everything. So concept map on this diagram very much is not mapping from a code in a code system to another code in a code system in a really general way. It's mapping from a code in a value set, and a value set is selecting a set of codes for a particular purpose. So the context of why the code is in the value set is also part of the context. To same thing, a target value set and the same issue, and then the map adding extra context on top of that. So it's all quite specific. But that said, obviously, there's some things that are really big maps that people created, and maps are a lot of effort to create and to maintain, and they may be largely the same for a number of different use cases. So you might want to actually say, I want exactly that concept map with thousands and thousands of things in it, but I only need to tweak like a few things. So you could take a copy of it and change it, but then you've got to own it and maintain all of the rest of it as it changes, and that's all kind of horrible. So another thing you can do is to sort of compose the concept map by providing a concept map which has just got the bits that you want to override about the base concept map. And then for everything else, that concept map that you create with just the changes delegates on to the original big concept map. And that's sort of what that's trying to show on the bottom there. So this is using the unmapped section of the concept map. Here's a few examples of what you can use. So you can actually say when something's unmapped, you can just say use the source code, which is just echoing back what you passed in, more or less. You can use a fixed code to say whenever something doesn't occur in this map, then just send back this. And then what we're using here is other map at the bottom. So we're saying go and delegate onto this other maps URI. So here's an example of a concept map, a really simple one that I stole off our server that's between states of Australia and their capitals. So New South Wales, capital is Sydney; Queensland, capital is Brisbane; South Australia, Adelaide, and so on. So this is a toy map that we have in our server. I don't know how much people would actually know about this, but we had a rugby league match recently, and Queensland defeated New South Wales, which is a common occurrence. So this fictitious example that I've got is going to show you what happens if you want to say, for the moment, because we won that, Brisbane is going to be the capital of New South Wales until they get their act together. So when you have a look at this example here, this has just added this particular mapping between New South Wales and Brisbane. And then for everything else, it said other map, go and talk to that AU States Capitals concept map. And so we've got our AU States Capitals customized is this map. So if I call translate on this custom map, so I'm calling it on AU States Capitals customized, and I'm calling and saying, I want to know what the capital city is from the target value set there. I want to know what the capital city of New South Wales is. And then the response that's going to come back from the server here is to say it's Brisbane, B&E. The interesting thing about this, that it's responding with equivalence of Brisbane to say that there, is that it's telling you where it got that. So this is saying that mapping that it just returned to you, that came from AU State Capitals customized, not from the base map. But if we do the same thing for asking what Victoria is, and we're asking that of the AU State Capitals customized, so we're asking the customized map, what's the capital of Victoria? It's going to respond still with Melbourne. And when it tells us that, it's going to say that's come from this map, that's come from the base map. So you still know where your matches are coming from. So I think we've used quite a bit of time. So to go through, just to cover off what I talked about, we looked at CodeSystem Supplements and what they are, what they're for, how they work, how you use them. Looked at implicit value sets and how useful and powerful they are for doing ad hoc things, particularly being cacheable, and they can be used for sort of providing dynamic functionality as well, which is pretty good fun. Really good for SNOMED CT ECL, but then another plug for Michael's talk on bringing that to everything else as well as SNOMED CT. Had a look at transitive closure and what that is and why you might want to use that and how to use it. And then also how and why you might want to compose concept maps. And it's also a similar concept with value sets. You might want to do that too. And rather than redefine someone else's value set with some tweak in it, you can say, I want everything from their value set, and then with these additional rules on top of it for maintenance purposes. So I'm around for the rest of the conference. So if you're interested in any of that stuff or any of the related terminology stuff, I'm happy to talk. Otherwise, yeah, hope you have a good conference. Any questions?
Thank you very much, Dion.
Yeah.
So we still got 10 minutes time for questions. So I already see here from the audience.
If you build like value sets, thanks for the talk, by the way.
Yeah, no worries.
If you build value sets with ECL expressions and you have like multiple inclusion rules with ECL expressions, and then you expand that value set, what determines the order of the concepts? Like suppose you don't use a filter, but just expand the value set.
Yep. Yeah. Look, that's essentially up to the server. And I mean, if you haven't used a filter, then it's kind of arbitrary as to what it wants to return those concepts in. Yeah. But obviously, if you provide a filter, then it's kind of what the server's going to do is return them in the best relevance result ranking that it can give you for that filter that you've put in.
Do you guys use the composition order?
No, the composition's really just used to determine what should be a member of the set or not. And then there's a ranking that occurs after that. And the ranking is using things like the preferred term versus the other synonyms that exist for this thing, the other synonyms that exist and terms that exist for all the other concepts in the set. And yeah.
So you shouldn't use a supplement to add a new code. You should instead send a request. But what should you do in the meantime? What's your recommended best practice?
Yeah, this is a difficult problem and it comes up quite a bit. Yeah, thanks for the question. Can we go to the next one? No, yeah, it is problematic. There's a few different strategies. I mean, you can create your own code system and then ultimately you end up with a value set that's got codes in your code system and codes from the base code system. And then you can retire them and move them over, and that's all kind of messy. There's not really a great sort of answer for that at the moment, but it is a problem, and it sort of certainly happens in some cases with even code systems like Loink, where people want some code that isn't, is going to be part of Loink, but it isn't part of Loink yet, and it's not official, and then maybe it makes it in, maybe it doesn't, and so we see that a bit with Loink particularly. So yeah, if you've got any good ideas.
Copying FHIR's extensibility mechanism would be nice, because in FHIR you can make an extension, you can submit a request, and if the semantics in a final resource are the same, you can just pretty easily migrate your data from the extension to the new thing.
Yeah, no, we definitely need a resolution mechanism for that, because it does come up a bit. Yeah.
Okay, then we also got one question from the online audience, which is, does the code system need to be hierarchical in order to be used in ECL?
Well, ECL only works for SNOMED because it's a SNOMED language. I think Michael's calling it VCL at the moment, but what he's done so far, you'd have to ask him whether it only works for hierarchical. It shouldn't need to, because it can work off the properties of codes as well. Obviously, if you've got a code system that doesn't have properties and it doesn't have hierarchy, then there's not much need for a query language for it, because there's nothing to query really. Yeah, the other thing that the query language can do is also use sort of in operations as well, a bit like SNOMED does for reference sets, but you can refer to a value set URI for that as well.
There you go.
Thanks. Is there such a thing as a supplement for a value set?
It's interesting you should raise that. I think Root would love an answer to that. She's been hassling us about it. No, and there are, I think the use case that Root has is for saying that she has a, she'll probably tell me if I get this wrong later, but that you have a set of codes. If you imagine like a table where you've got a list of codes and a list of maybe display terms that are specific to this particular use of this value set, and a particular set of properties that really is just for this value set. I think the only way to do that at the moment is to create a supplement and a value set and then use the supplement in the value set. I think what Root would like to do is be able to just put it in the value set because she's only using it in that one value set. But I mean, in a way, the supplements are ideally a thing of their own that add generally useful information that might be used by multiple different value sets in different contexts. But definitely you might have different supplements that are possibly even adding different values for the same property for different contexts. That I can imagine that's possible.
So if there are no further questions, I would like to thank you again for the wonderful presentation.
No problem.
Give it applause, I would say.
I am wrong. I am wrong. Does anybody see me?